cases, I will cross multiply, right? So I have A equals 20 plus 20b. And here I have 0.7 AB equals 12 times 1 plus B, everything squared. Let me see what I want to do. Yeah, I'm going to use substitution. I will replace this A in the second equation by 20 plus 20B. So 0.7, 20 plus 20B multiplied by B equals 12. I know you know that this is 2B plus B squared. It's going to be quadratic. I'm going to move everything to one side. Which side do I want to move it to? Doesn't matter. Okay, so 0.7 times 20 is 14. 0.7 times 20 is 14. This one gets a B, and this one gets a B squared. And then on the other side, I have 12 plus 24B plus 12B squared. I move everything. This will be a 2B squared. This is 14 and minus 24 minus 10B, and then minus 12. I'm checking my calculations. Yes. I bring this over, minus 10. I bring this over. I divide by 2. So this is B squared minus 5B minus 6 equals 0. Quite nice. So this is B minus 6 and B plus 1. So I have two options, B equals 6 and B equals negative 1. And now I have to determine A. With 6, 120, 140. And the other one with negative 1 is 0. Oh, okay. So we have two possibilities, 140 comma 6 and 0 comma negative 1. So I don't remember. I have to go back to the problem. I don't remember if we had any restrictions. Oh, yeah. We have a restriction. A cannot be 0. If A is 0, the entire function is 0. So that's not an option. Not possible. So the only possibility A140B is 6, A140B is 6 to fulfill the given conditions. So I'm going to write the function one more time so we have it with the parameters replaced. And that's it. So the function is 140 over 1 plus 6e to negative 0.7t. And there is only one possibility. I think I'm going to scan this again so we have, so when we finish 1, 2, I'm just going to scan these and then put page 3 and then page 4, so just in case. Okay. Anything else for me? I'm glad we finished that problem and I didn't forget. Anything else? So let's open 3.7. I have two types of problems to look at here. Any questions for me? Anyone? So I would like to look at a problem from the very beginning of 3.7 exercises. It's a long problem, but we learn a lot from it. So here it is from the very first set, problems 1 through 4 in this book, the older edition, but it has a lot of questions, A through I. And you will see it will teach us a lot of different situations, especially when the particle is slowing down and speeding up. It's a interesting situation. Okay, so a particle moves according to a law of motion. And the law of motion is F of t given to us, or S of t, doesn't matter, is t to the third minus 12t squared plus 36t. This is our given function. We are told that t, of course, time has to be greater than or equal to 0. T is in seconds, and S is in feet. Always remember the measurement unit, especially when we have answers, numerical answers. We have to present the measurement unit. Okay, first part. Find the velocity at time t. Can anyone tell us how to find the velocity at time t? Anyone?
You find the derivative of the position function.
Very good. So this is s prime of t. So can anyone help with that? Anyone I haven't heard from yet? Let's say Kush. Can you give us the derivative of this?
T squared minus 11t.
How do we differentiate t cubed?
What are we doing?
How do we differentiate t cubed?
Yes.
We bring 3 in front.
Oh,
So three.
Yeah, yes, 3t minus.
We subtract 1 from the power. Leonardo, will you help?
3t squared.
Yes.
And then it would be minus 24t.
Yes.
And then plus 36.
Good. Very good. Part A. Part B. What is the velocity after 3 seconds? Can anyone tell us what to do to find the velocity after 3 seconds?
Would we just plug in 3 to the derivative?
Very good. So please plug it in and tell me the answer. What do we get for V of 3? So 27 minus 24 times 3 plus 36.
-9.
Measurement unit?
Let's see, feet per second.
Very good. It's a velocity feet per second. This only means that the particle is not going in the positive direction. The particle is going in a negative direction. That's all it means. Okay, perfect. Moving on. Part C. In part C, when is the particle at rest? When is the particle at rest? What do I need to do? What is my car parked? Your car parked?
When the velocity equals 0.
Velocity equals 0. Very good, Derek. Thank you. Okay, so the velocity is 3t squared minus 24t plus 36 equals 0. What do you think we're going to have to do first? As one of my friends says, she says, always keep, or we're running a clean ship. So we're running a clean ship here.
Let's reduce it as much as possible. Divide by 3.
Very good. So then t squared minus 8t plus 12 equals 0. If factoring takes more than 20 seconds at the most, then we use the quadratic formula. Can we factor quickly or quadratic formula?
I think it's going to be some combination of 6 and 2.
Good. So then t equals and t equals. And measurement unit, because we write a number.
Positive 6 and positive 2.
Yes, measurement
it's
unit.
It's going to be, let's see, feet a second.
Good.
Or,
so
yeah, second.
When is the particle at rest? 6 seconds from the starting of the movement of the particle, and also 2 seconds from the beginning. Okay, perfect. When is the particle moving in the positive direction? When is the particle moving in the positive direction? That's our part D. Positive direction. Okay. Here is t. Here is v of t, or the derivative. Time is 0 to infinity, not really, but you know what I mean. We know that the velocity is 0 at 2 seconds and 6 seconds. And I need to determine the sign of the derivative. Find the sign of v of t. I'm copying v of t right here, so I don't have to go back to it over there. So 3t squared minus 24t plus 36, or, which I really prefer, 3t minus 6, t minus 2. Good. So I need a sign here, here, and here. You can plug in 0 and tell me the sign. You can plug in 4 or 3 or 5 and tell me the sign. You can plug in 100 or 10 or 15 and tell me the sign. There is a much easier way to determine the sign, and I'll show you in a minute, but after you tell me the sign. What is the sign of the derivative between 0 and 2, between 2 and 6, and between 6 and whatever? Josh, will you tell us the sign to the left of 2?
I think it might be positive.
So to the left is absolutely positive. Between 2 and 6. GL, you say it again.
Negative.
And between 6 and whenever?
Positive.
Positive.
Right. We don't really have to plug in anything. This is a quadratic function with a positive slope, so with a positive leading coefficient, I meant to say. So it opens up. And if it crosses at 2 and 6, it's positive outside and it's negative in between. We don't really have to do that. That's the easiest way to think about it. But because we're not going to be able to graph all possible functions, so there are other ways, and I'll show you later. But because this is quadratic with a positive leading coefficient, which means it has a minimum, outside must be positive and in between negative, because it crosses the x-axis. If it's like this, it doesn't cross the x-axis, it's always positive. And even if it's like this and it only touches in one point, it's always positive, except here where it equals 0. Okay, good. So I will say, conclusion, positive direction, because the velocity has a direction that is positive. Negative, between second 2 and second 6, it's negative. So in other words, between 0 and 2, it's going this way. Between 2 and 6 seconds, it goes this way, and then it comes back. And this is positive. And it will always be positive, going the positive direction according to the function. Perfect. Part E. Find the total distance traveled during the first 8 seconds. Total distance between 0 and 8. So notice now that I can go back to my table and say, I really don't want infinity. I'm just going to put 8 here, because this is what I'm given in the next question. So I'm interested in the particle going this way for 2 seconds. 0, 1, 2. It's right here. It turns around and it goes back for 4 seconds. 1, 2, 3, 4. Between second 2 and second 6. So this is 6. And then he comes back 2 more to second 8. So 1, 2, 3, 4, 5, 6, 7, 8 seconds. So this is in the positive direction. This is in the negative direction, and this is in the positive direction. However, it doesn't matter if it's positive or negative, the direction. The total distance will equal S2 minus S0, the absolute value, plus the absolute value between S of 6 minus S of 2. Even if this is a negative direction, it still accumulates distance. And then plus the absolute value between the difference of S of 8 minus S of 6. So now I'm going to share my screen. We're going to enter this function in the calculator. So the function S of t, 3 pages earlier, okay. So we have x to the third minus 12x squared. And then plus 36x. And go second in table. And I put in all these numbers. Which numbers? 0, 2, 6, and 8. 0, 2, 6, and 8. And I copy them now directly where they belong in my absolute values. So S of 2, 32 minus 0 plus S of 6, 0 minus 32, and plus S of 8, 32 minus 0. I'll stop sharing now. So here's what I have. 32 minus 0 in absolute value is 32. 0 minus 32 is 32 in absolute value is 32. And again 32, so 96. Measurement unit. Perfect. Thank you very much. So this was the total distance E. Draw a diagram. We already drew the diagram. So the diagram is part F. Okay, part G. Find the acceleration at time t and after 3 seconds. How do I find the acceleration?
You take the derivative of the velocity.
Very good. So who knows where the velocity is? So the velocity is right here. I'm going to copy it. So 3t squared minus 24t plus 36. So now we want to find v prime of t, which is a of t, which is s double prime of t. Can anyone help with the derivative?